Okay, today we're talking about 11.4 volumes of prisms and cylinders. We should all have our notes out, following along, taking notes, writing down whatever I write down, and paying attention, listening closely. So, volume of prisms and cylinders, all you're doing is finding the area of your base and your height. So, area of your base and your height of your prism or cylinder. Okay, now our base can have different shapes. Luckily, we spent a whole chapter on how to find the area of bases. In this case, you have a rectangle. In the case of a cylinder, you always have a circle. Prisms, you might have like hexagons and stuff that we looked at earlier. Either way, you have the area of that base. So not just a one-dimensional part of our base, but the area makes it two-dimensional. Okay? So to find volume, you're finding the area of your base. There is not a specific formula for area of your base because your base shape can differ. So there's not one set in stone formula to put in for volume. It all depends on what the shape of your base is. Regardless, for volume, this big B stands for the area. Okay? So again, you should be multiplying two things here to find your area. If it's a triangle, you're taking half base height. If it's a rectangle, just base times height. Circle, obviously, pi r squared. So to find volume, you're finding the area of your base times your height of your prism. And remember, height always makes a right angle with your base. Okay, so that's a pretty broad formula for volume, but we will power through. So finding volume of this rectangular prism, first thing I need to find is my big B. Big B stands for area of my base. In this case, my base is a rectangle, since we have a rectangular prism, and I'm going to consider the base to be this rectangle that is 5 by 3. Find the area of a rectangle, you're just taking base times height, 5 times 3, my area is 15. So when it comes to my volume formula, where I have the area of the base times my height, this is the area of my base, so 15 times the height of my shape, the height is 4. So my volume is 60 feet. When we label volume, we talk about cubed. Volume is about what's inside our shape. We talked about surface area, which is the outside, like if I was going to wrap something. Volume is like if I'm going to fill my package with the popcorn paper filler. Okay? We have 3 dimensions. It says, suppose a prism is turned so that the base is 4 by 5. So instead of having that blue base of 5 by 3, it says, what if you have the 4 by 5 base? So if I'm looking at this front side of my base instead. Okay, so if I find the area of that base is 4 by 5, so that area would be 20. And then when I go to plug into my formula for volume, area of my base times height, area of my base this time is 20, but that also changes my height. If this red is my base, that means my height is this 3. Okay, it's kind of like the only number you haven't used yet. That still gives me a volume of 60 feet cubed. Okay, so to answer the question, does the volume change? No, volume doesn't change. The volume isn't going to change based on what you consider your base. And I think in some instances it's going to be a lot easier to consider your base one shape as opposed to another. But especially your rectangular prisms, it's not going to matter what you consider your base. If you look at the front, top, right, bottom, whatever. Just as long as you are only using each number once. And remember, our bases are always parallel each other. So like if I look at this triangular prism, our base has to be the triangle. Okay, remember bases don't ever touch. They're the parallel things, front and back, top, bottom. They never touch. And then we have the rectangles in between that give it that lateral area we talked about with surface area. So in this case, my base is going to be my triangle. And I need to find the area of it. Again, we got that triangle. And remember, your base and height of a triangle have to make a right angle, which in this case we have. So whether you want to say your base is 10, your height is 6, or your base is 6, your height is 10, it's not going to matter, okay? Formula for area of a triangle is half base height. Like I said, you can pick either 6 or 10 for your base. I'm going to choose 6, which makes the height of my triangle 10. And so for the area of my base, I have 30. To find volume, I have area of my base times my height. Area of my base I just found to be 30, which means my height, in this case, I think of it more as depth, but also the only number you haven't used yet is 5. So I have 150 labeled meters cubed. Okay. In our reasoning question, it says, suppose the height of a prism is doubled. How does this affect the volume of the prism? Okay, well, if I use that last example that I had, where my height was 5, if I double that, my new height would be 10. So leaving the area of my base the same, but changing my height to 10, so doubling my original height was 5. If I double it, my new height is 10. Hopefully that makes sense. That would make this new volume 300, not feet, my bad, meters cubed. So comparing the 150 and the 300, my volume is also doubled. So doubling the height changes the volume by doubling as well. So volume would be doubled as well. Okay. Moving on to our next page. We have a triangular prism again. So that means that my base shape is a triangle. I'm going to try to do this all in one. So volume is the area of my base times height. In this case, I said my base is a triangle, so my formula for triangle, half base height times the height of my prism. So this height is just my triangle height. This height is the height of my prism, the thing that gives it depth or height. So turning it from that 2D shape to that 3D shape. So if I look at my triangle, this guy right here, notice this is 8, so this side has to be 8. I have an equilateral triangle. My base of the triangle is going to be 8. I'm going to draw another one here. So these are all 8. My base is 8. I need to find the height of it. Oh, looky, looky. We got a 30, 60, 90 triangle, which makes this side half of 8, aka 4. And the height of it, 4 square roots of 3. Hopefully we remember these, kids. The height, the only number I haven't used yet, is my 10. That is what gives it that 3D look, is that height of 10. Multiplying these all together in our calculators, I get 160 square roots of 3, which is about 277 inches cubed. Okay, pause me if you need to. I'm going to move on Volume of a cylinder. Again, we're going to treat this all in one formula. Volume is area of my base times my height. Cylinders always have a base shape of a circle. To find the area of a circle, I have pi r squared, and then that height that we're going to have 8 in there. This one gives you the straight up radius. Don't even have to half it. Yeah, I'm talking right. My radius is 3. The height is 8. So leaving it in terms of pi, 3 squared 9, 9 times 8, 72 pi, label, centimeters cubed. Again, pause me if need be. Volume of a cylinder, again, in terms of pi. So you don't have to multiply it out. If it didn't ask for in terms of pi, you would just take in that last one, like 72 times pi, times 3.14. Volume, again, area of my base times my height. Again, I have a cylinder, so my area formula for circle is pi r squared. This one, it gives me my diameter, so my radius is only 1. The height of my shape is 3, so leaving it in terms of pi, 3 pi meters cubed. Okay, kind of working backwards, it tells me the volume of the cylinder is 135 pi centimeters cubed. The height is 15 centimeters. I need to find the radius. So we have that standard formula, area of my base times my height. Since we're talking about a cylinder and the radius, you know that my base is a circle, so that pi r squared, and then obviously height for my cylinder. I know that the volume is 135 pi, so I'm plugging that in for V. I do not know my radius, but I know my height is 15. So you are going to divide each side by 15 pi, trying to get r by itself. You have r squared left, don't forget that. 135 divided by 15 is 9. Get r completely by itself, you have square root, so r is 3 centimeters. My radius is 3 centimeters. And the last one, I got a fish tank, or an aquarium, sorry. And we need to find the approximate volume. If you notice, this shape that you start out with, and then it breaks down for us what's going on. We have a rectangular prism, and then like part of a cylinder, specifically half of a cylinder. So we're going to find the volume of our rectangular prism first, and then our half a cylinder second. So, start with our prism. Volume is area of my base times my height. In this case, I am going to use, I don't want to move up too much. I'm just going to use the front as my base. So this has dimensions 24 by 36. And then just using the only number you haven't used yet, 24 for my height. Multiplying that all together, I get a lovely huge number, 20,736. Finding the volume of my half cylinder, I have area of my base times the height, but remember I only want half of it. Half. My base shape is a circle, pi r squared, and then my height. Notice it has labeled the radius for you, 12. If it didn't, this whole side that it matches up with is 24, so half would be 12. Either way, thank goodness we get the same number. And then the height is 24. Again, they didn't have to label it for you. It has to have the same height as that guy. But they were just super nice to get that. If you put that all together, even multiplying out pi, because kind of like we talked about Campbell's soup label and the filter paper, you cannot tell aquarium people numbers in pi, so you're going to have to multiply it all out. You can use 3.14 or your pi button, so my number might be a little bit off if you use your pi button, but 5,425.92 for the half cylinder, and then volume, putting it all together, 26,161.92 inches cubed. So our little fishies got lots of room to swim. Well, maybe not, that's in inches. So, alright. Enjoy the day, kids.